Hi, in this video, we want to take a look at moderator and mediator models. Okay, so the idea here is that I've got X and Y, just like with any other statistical modeling that we've got. We've got X and Y variables, and we're looking at Y as the dependent variable and X as the independent variable. But there is another variable, and we're going to call that Z or M, depending on what we're doing at which part of the video, that has an impact on what happens between on how much of an impact X has on Y. All right, so like a moderator interacts directly with X. Okay, so here, this is rather important. A moderator interacts directly with X, and so from a statistics point of view, when we're talking about moderators, we're actually talking about like interaction models. Okay, so what's going to happen here is that that third variable is going to impact the amount of influence that X has on Y. So now the impact that X has on Y will go up or down depending on the value of the moderator variable. Okay, so algebraically, how we usually present these are interaction models. But if you were to hand me an interaction model and go and tell me, oh, which one of this is the moderator, which one is the independent variable, we won't know off of the standard like modeling scheme. Now we have to use like subject matter knowledge about which one is the independent variable and which one is the moderator. Now a mediator is different, that it acts in between X and Y. Okay, so with a moderator, here's an example. If X is alcohol consumption and Y is social acceptance, Z is social context. Okay, so if we're drinking alcohol, that might, and it's a socially acceptable situation, people might be more receptive to me if I drink. So if I'm at like an annual party for a brewery and I don't drink, I'm probably not going to be accepted, right? If I don't drink. But if I'm at church and I don't drink, and it's the church has strict alcohol views, then that's going to be a very different situation. Now, a mediator is something kind of different. If alcohol consumption is my X, and waking up in jail is my Y, my mediator is going to be like driving back home while I'm drunk. So you can see how the probability of waking up in jail would skyrocket if I've been drinking and I drive back home. Now, if I've been drinking, I don't drive back home, I still have a probability of waking up in jail, right? That could happen while I'm walking home, while someone drives me home. So the moderator is more directly involved, while the mediator is like somewhere like in between the two events. All right, so let's go ahead and load some data, take a look at it. So for this example, we're going to take the packed van data set from the MPsychoR package, and we've got two indicators and two factors to work with. So peak climate and work intensification are our indicators, and then our factors are going to be co-gap and emotion. Now, something I'm going to do with this, and this is different from what the author did in the textbook in their code, I'm going to rescale everything. And the reason why I'm rescaling everything is to make things easier for me to interpret as I work through the example, as I look through. Now, if I was doing this for a real project, one thing that I do frequently is I'll rescale my variables, work through the project, get a feel for what's going on, because there, if everything's rescaled, it's easier for me to interpret. And then I'll go back and rerun the analysis without scaling, and because then I've got a good idea of what I should and should not be doing. All right, moderator models. Okay, mathematically, moderation is expressed as interaction. So if I want to do this just from a straight linear regression point of view, what I can do is just have an interaction term between Z and X. If I do interaction with Z and X, where Y is the target variable, I can just jump right at it. And what we're doing is we're saying that, like in an algebraically kind of difficult to spot manner, we're saying that the intercept and the slope are linear functions on the z variable in this situation. Now we could choose more exotic functions for this, but in the literature, from what I've seen, it's always a linear model, and that linear model can be rewritten as interaction. So we just do interaction because that's more comfortable, that's more familiar with what we're used to. Now we can also approach this by using functions in R that are already set up for doing this. And so we just have to tell R what's X, what's Y, and what is the moderator variable. And it'll run through it. Now, this MC parameter, this is saying, did I center the data already? And yes, I did. So this package likes to have the data centered. So, and if we don't center it, it will go ahead and do it for us. So I just went ahead and did it for manually. All right, in here, when we do that, we get output that looks a lot like standard linear regression models. And you'll notice that we have an interaction term right here, and we have an X, and we have X, and we have Z. Now, something I can do if I want to get a confidence interval on the slope. So remember, now I'm saying that the slope of X, so Y is the target variable, and it's modeled by the X variable. The slope is dependent on Z is my model, and the intercept is dependent on Z. So what I want to do, I want to get an intercept and slope like confidence intervals. So what I can do like a simulation, do some bootstrapping, and I can get an idea of what's going on. And so here gives me upper and lower bounds on confidence intervals. And you'll notice that it's saying with regard to high and low values of Z and median values of Z. Because if I have a more exotic situation, it may not be an interaction model. It may be something more complicated than a linear model on that. The slope may not be a linear model on Z. So then I might have something more exotic. I might not know it at this point. And so here, this is working to try and show me, is there something more interesting going on, so I can start digging in and looking at this more precisely. Now, a mediator model, this is where the Z variable is like in between X and Y. It has more of an indirect effect. And the indirect effect is not normally distributed in general. And so one thing we're going to want to do, we're going to be using Bootstrap to get our confidence intervals. Now, in a moment, we're going to look at some output, and ACME is average causal mediation effect. All right, so let's go ahead and use the mediation package for our mediator model. Okay, so what I'm going to do first and foremost, I'm going to build some linear models that I'm going to use in a moment. So I'm going to model cogap based off of perceived intensity. Now, I've already rescaled everything, so I'm going to go ahead and drop the interceptor term because whenever I'm doing simple linear regression, the model always goes through X bar, Y bar. Well, if I've centered and scaled my data, X bar is 0, Y bar is 0. Therefore, it's going through the origin. There's no point in having an intercept on there. And so here we get the output. We can see the estimated slope overall is about 0.6, statistically significant. And our R squared is not really great, a little bit less than 0.4, but it is statistically significant. All right, let's see what happens when we move forward. Now, what we're going to do, notice that cogap is a dependent variable up there, right? Okay, so it's the dependent variable on perceived intensity. Now I've got perceived intensity and cogap in the model down here. Let's run that linear model. What's going on is that we have a system of equations that's a little bit more exotic. And if you look at the textbook, it'll explain it out that we have like a system of equations where we have our mediation variable M in there inside the system of equations. We have a regular standard linear model from here. So the equation that corresponds to that. Then on the next line, we have our M corresponding to one of the variables inside here. Now let's take a look. All right, so we have statistical significance. All right. So something to think about is that COGAP depends on intensity, right? But then emotion depends on intensity and COGAP. So it's like intensity is actually influencing emotion two different ways. And so this is why this is a special type of model. All right, so now let's go ahead and use the mediate for the mediation package. And let's run through this. So here, this is model of the mediator is going to be COGAP depending on intensity. And then our Y is going to be emotion. So our Y variable is emotion, and our mediator is COGAP, and our X is perceived intensity. And we're going to do bootstrap. We're going to do a simulation 1,000 times. Let's look at what happens. And so right here, we can get our confidence intervals. We get our lower and upper. Lower and upper. And you notice I'm not seeing 0 inside any of these intervals. All right, now that's one way to do this. So how we got this was we did linear regression, and then we did some bootstrapping with the mediate function. We can achieve this with the Lavon package. Remember, Lavon is the latent variable analysis package. And if you're doing this type of modeling anyway, you're probably using this package. So this is a very natural extension to what we've already been looking at. So what we're going to do here, we're going to say that emotion depends on perceived intensity and COGAP. We're going to say that COGAP depends on perceived intensity. Now, something that's going on, this is a coefficient, and I'm writing target variable. I'm writing dependent variable, independent variable, dependent variable, independent variable in my coefficient. That way, when I look at the output, I know which ones are connecting together. That way, it's easier for me to read. If I was to do like beta 1, beta 2, beta 3, beta 4, stuff like that, I would have to like basically make a dictionary to figure out what is it that I'm interested in. What am I looking at? I'm too lazy. I'm just too lazy to do that. Now, we're going to have an indirect effect. And so here, you'll notice that this is the emotion COGAP and COGAP intensity. So we're taking the coefficients from here and here and multiplying them together, and that is our indirect effect. Our main effect is going to be that indirect effect that we just talked about, the product of the two coefficients plus the other coefficient that we haven't used in these equations yet. And then our mediation proportion is going to be division. So this is going to be the indirect effect divided by the indirect effect plus the emotion intensity coefficient. And we're going to use the SEM function in the Lavon package. We're going to bootstrap this bad boy, and we're going to do 1,000 iterations. And we're going to use parameter estimates to take a look at what's going on. And now, after I do this, I want to take a look at the confidence intervals to see what does the output look like. All right, so here, I'm going to grab all the formulas that correspond to regression. And we can see that 0 never goes through any of them. So I'm confident that the coefficients are not equal to 0. And the dots give me the estimated values. Here, we're going to look at the residual covariances. All right, so here, So there it's 1. And we got that we are our intervals. So we're modeling that we do not have independent covariances with respect to these variables. Or so we have non-constant variance. And now we're going to look at this like indirect operator, direct operator. And here we're spitting out the relationship between the individual terms. And we have an idea of what's going on off of these confidence intervals. Now let's go ahead and look at the path plot. All right, so if I look at the arrows, I can see that intensity is leading into cogap, and then cogap leads into emotion, and then intensity also goes into emotion. So intensity is impacting 2 different variables, but motion's getting hit by both of these guys. Now, we can combine these to get moderator and mediator models if we want to kick it up a notch. So here I've got perceived intensity, then climate, and then I have interaction term. And then emotion is depending on intensity and cogap. And now we're going to go a step further. We're going to look at the quantiles of the values that we'll get from here. So this comes from exploring some values beforehand. But we take some quartiles. We get the first quartile, the median, and then the third quartile. Compute them. So we're getting the quartile on the P climate, and then I'm slapping them into here. So what I'm doing, you can see that I'm replacing the P climate term with the quartile. And that way I can go through and work out aspects of what's going on. Once again, we do a bootstrap. And then we do our path plot to get an idea of what's going on. And we can see that it's a lot more complicated, but that's not surprising, right? So here we've got our interaction term. Our interaction term is kind of like going back and forth with P climate and intensity. The interaction term is impacting cogap. P climate is impacting cogap. Intensity is impacting cogap. And then both of these are leading into emotion. And once again, I want to look at the confidence intervals to see, should I reduce this model? Because right now, this is kind of hard to wade through. I mean, this is a lot. I've got arrows going all over the place. Can I reduce this down? If I can, I will remove a term, rerun everything, and look again. Can I remove anything? And repeat until I can't remove anything else. And I look at it, first and foremost, I look at the terms that are involved for regression, and no, I can't remove any terms. Nothing's crossing 0. I want to look to see with regard to covariances. Nope. And then we want to look at our direct and indirect effects, and no, so this is as simple as I can make it. So what I have to do now to use this model, I have to go through, I have to make sure I fully understand the data. I have to fully understand what was being measured. I have to make sure I understand how are these impacting each other. It might be that this is algebraically too simple of a model for the situation, which looking at that, I think that's the case. But I might not have data that can fully achieve the true complexity. So when I would, if this was a real project, I would sit down at this point and try to look at how things change when I start messing with the mediators and moderators. All right. Well, that's all I've got for you. Take care and goodbye.